and breakout rooms not. So only these parts where we are all together will be recorded. So my name is Łukasz Szuszkiewicz, and I am an adjunct professor at the Faculty of Law and Administration of the Adam Mickiewicz University in Poznań. It is a great pleasure to welcome you all to the Summer Institute in Computational Social Sciences, organized together by the Faculty of Law and Administration in partnership with the Faculty of Mathematics and Informatics of the Adam Mickiewicz University. The event is funded by the Social Science Research Council, a US-based international nonprofit organization, and Adam Mickiewicz University through the fund of University of Tomorrow. In Polish, it's Uniwersytet Jutra. Right now, some 600 participants in 30 locations worldwide are beginning their journey with computational social sciences, and you are among this group. Throughout the next 2 weeks, you will have an opportunity to learn programming and different research methodologies, apply them in practice, and even design your own research project. The idea of this event is to establish a learning community where you learn from our distinguished speakers, but also from us and from you as participants with great expertise in different areas of law. Together with us, we have a Vice Dean for Research and International Cooperation of the Faculty of Law and Administration, Martina Kusak, who is pursuing actually research in AI, big data, and algorithms with a particular focus on law enforcement. She was the first person with whom I shared the idea of organizing the institute at our university. And from the very beginning, she was very enthusiastic and supportive, and I am more than happy that she is with us today. Dear Martina, the floor is yours.
Thank you, Łukasz. Ladies and gentlemen, dear speakers, participants, and organizers, it is my honor and pleasure to welcome you on behalf of the Faculty of Law and Administration of the Adam Mickiewicz University in Poznań to the Summer Institutes in Computational Social Science, sponsored by our faculty in cooperation with the Faculty of Mathematics and Computational Science. As Łukasz just said, our faculty from the very beginning has been supporting the idea of this event, given we share a common interest in regard to computational social science. This area, computational social science, it's an emerging discipline at the crossroads of data science, computational modeling, and social sciences, which seeks to exploit the growing availability of digital trace data and computational potential to describe aspects of our society that are very difficult to capture by traditional means and methods, including legal methods. We all, as lawyers, social scientists, and society, look forward to new knowledge generated through computational methods. That's why the importance of investing in research on computational social science in the legal area has been recently pointed out by the Joint Research Center of the European Union. Therefore, I am particularly happy that our faculty will contribute to the development of this field. I must admit that was truly impressed by the wide variety of topics and activities undertaken upon this project, ranging from programming, measuring human rights, survey in legal research, and exploring big data sets which relate to European Union. It makes me proud as the faculty member and also satisfied as academic with particular interest in this topic that you are so much eager to leap forward on so far underexplored areas. And this, as well as the profiles of speakers, participants coming from all over the world and representing various academic and professional areas, makes me sure that the time spent virtually at our faculty will be full of new experience, networking, and friendship built on the common interest in computational social science. Having this opportunity, I would like to thank Łukasz for bringing the idea of organizing this event at our faculty, as well as a team composed of Wojciech Biernacki, Igor Gontarz, and Jędrzej Wydra for being eager, determined, and I would say a bit crazy enough in making it happen. I know how much time and dedication it requires to organize such event. And having said so, I wish you 2 weeks of fruitful interdisciplinary sessions and workshops lively debates, and integrating cross-cultural experience. Thank you very much for your attention and for having me today.
Thank you very much, Martina. Exactly, as Martina mentioned, the idea of the whole event is also to have all of us together so we can network with each other. Maybe we can also work in the future on the common projects, because that's something that I will introduce shortly. So due to the online setting that we are, I kindly ask you to turn on your cameras so we can have a more that personal feeling. And in particular throughout the group exercises, but also during plenary sessions, and also, you know, to show the speakers. We are in purpose. The idea from the very beginning of the institute was to have relatively small group, to create proper group dynamic, to share openly our ideas, also in a setting where we can all talk with each other and meet and know with each other. And this is also why all group exercises will be solved in small groups. Every time you will be assigned to different persons, so you will have a chance to know all participants throughout the whole first week, actually. So I will move now to some logistics, and maybe I will briefly just introduce the organizing team. Martina mentioned that there are Igor, Jędrzej, and Wojtek from the core team. Igor is actually is actually a project manager, but also a participant. It's Igor Gontarz on the list of participants. So he's a PhD candidate at our faculty, and he was the second person to whom I went with an idea, because I knew that Igor is an extraordinary in terms of organizing different events. And that was true, because we received around 50 applications. So there was really a big interest in this event, thanks to whole organization undertaken by Igor. And Igor liked the idea so much, the program, the curriculum, that he decided that he will be a participant. So here he is. Then we have Jędrzej Wydra, who is actually both a PhD candidate at our Faculty of Law and Administration and also MA student on mathematics and informatics. And he's also our head of programming team. Has extensive knowledge of R, more than 3 years experience in programming in R, and a perfect knowledge of maths, basically. So he prepared all the bootcamps for you. You are free to use code that he prepared in the bootcamp. In general, all exercises are also designed by Jędrzej and also his supported by his teaching assistants, which I will introduce shortly. And feel free also to approach Jędrzej, who will be available on Slack and on Zoom during group exercises, and also throughout the whole summer school, so the next 2 weeks. Then we have Wojtek Bernacki, who is again PhD candidate at law at the Faculty of Law and Administration. He's focusing in his research on EU law, IP property. So he will be also supportive in terms of conceptualizing things. He's also practicing law, in particular IP law. So feel free to approach Wojtek with some questions. And we have also teaching assistants who are not with us currently, but will be joining during different activities. So we have Małgorzata Jurczak, we have Mateusz Gruszczyński and Anna Hołdyńska, and all of them are students at the Faculty of Mathematics and Informatics, and they prepared bootcamp and also exercises for you. And also the last person that was very supportive, like Dean Martina Kusak, was Vice Dean for International Cooperation of the Faculty of Mathematics and Informatics. It's Professor Tomasz Górecki, who was actually supervising preparation of the bootcamp, of the exercises, and who will also deliver a lecture on using maps in basically research related to electoral law and also law enforcement. So this will take place on Thursday. This is our team. Feel free to approach us individually on Slack all the time throughout the whole 2 weeks. We will be there to answer your questions, either on conceptual side or purely related to programming. With programming questions, please approach Jędrzej, who is the head of our programming team. So, few words about the general structure of the Summer Institute. So we follow the general structure proposed by the Duke University and Princeton University, who invented the whole idea of SICSS. So the first week is dedicated to lectures and group exercises. And the second week is dedicated to implement your own group projects. In the first week, typically, every day looks in a similar way. So firstly, we have either a lecture or exercises, and we also finish with either exercises or a lecture, all exercises built on the code and the knowledge that you received through going through the bootcamp, and they are also closely related with the lectures. So these are like one bits. Today, for instance, we will cover the topic of natural language processing. So it will be introduced by Michal Ovádek, who is actually an R developer who developed the EURELEX package. It allows to easily extract information, EU law actually, and analyze it in R. And then we'll have exercises prepared by Jędrzej and his team that build on this package. In general, or exercises to implement and finalize for all exercises, you will need the code that was prepared on Bootcamp, so you can find it on Slack. And 95% of tasks that you will be assigned can be finalized with using only this code. Sometimes you have to change arguments. Sometimes you have to, for instance, add an additional line from another place of the bootcamp, etc., etc. Nevertheless, if you are familiar with bootcamp, you will be able for sure to complete most of the tasks, let's say. In general, we will have lectures in a setting like this, so a plenary session. And when we'll have group exercises, we will go to the breakout rooms. So in each breakout rooms, we will have 4 or 5 persons, and you will be working together on solving tasks that we prepared for you. During this time, we will be all the time available here. And if you have any questions related to the task or the code that you are writing, feel free to ask us, and Jędrzej will be here to come to your room and investigate the code that you wrote. So you receive the support throughout the whole group exercises. Plus, also there is a time. There is a time frame for individual consultations with programmers between 7 and 8 p.m. every day. So if you would like to really dive into programming and you have really specific questions related either to exercises or anything else that goes beyond, for instance, feel free to notify us that you would like to attend individual consultations. And to make it as efficient as possible, we advise you, if you have questions related specifically to code that you wrote, for instance, during exercises, the best way is to share the code an hour, 2, 3 hours in advance. So Jędrzej has time to read it, to understand it, and really help you in the most efficient way. Because sometimes it takes some time to understand the logic behind the code. And so the earlier you share it, the better response you will receive. And at the end of group exercises, we will come back to the plenary session to summarize it, wrap it up, to exchange experiences, to talk what was the main obstacle, what was the most challenging, was it easy, was it too easy maybe, we can make it more complicated for the next day, etc., etc. So there will be always a place and a time to share your experiences and also prepare for the next day. And in the second week, we will divide you into groups, and you will be implementing your own research projects. So the idea is that you will create between 4 and 5 groups, and you will be working on your own in the second week, and we will provide you support of programmers throughout the whole week. So if you have any obstacles, you can always approach us and we will help you with either coding or conceptualizing the project. Thinking how we can divide you into groups, we came up with an idea of sharing videos and concept notes that you prepared them in advance, and during each day we can discuss 2-3 of them in a breakout rooms during lunch sessions. So we'll have a brown bag lunches. Feel free to bring food that you like, and in the breakout rooms during the lunch break you can discuss the ideas, and it might happen that, for instance, you will find an idea of someone's interesting and you would like to join forces and implement a project on the topic. It may be the case that you have similar idea and you will merge those. It may be the case that you will, during the discussion, you will decide that you will implement a completely different project in the second week. And if you would like to share your ideas, feel free to send either a concept note or video on Slack or on email by today, 23:59 p.m. So we can prepare those for the next days, and we will post it on Slack, of course. Every day you will get a link in the morning to 3 concept notes and videos, and please just keep them short, because this is just an idea that you should spell out, and you know, interest persons, maximum 5 minutes if it comes to videos, and maximum, I would say, 2 pages if it comes to concept note. And if you will get an idea later during the institute, it's also fine. Feel free to share it with us so we can share it with other participants, and you can discuss different ideas for the projects. And talking about the projects, we will finally establish groups on Monday, next Monday, during an open space exercise. If you are familiar with open space, that's perfect. If not, don't worry. It's a really great methodology of creating groups that are interested in a very specific topics. And as I mentioned, you will be able to work with your group on the project that you would like to, on the topic that you would like to. It can build on the knowledge that you gained during the institute, or it can be, it can go beyond even. That's if you think that you would like to implement a project on something that is only a bit related with the topics that we covered, but it's still related to computational social science, feel free to go with that idea. And we will have a presentation of your findings on the very last day of the summer school, so on Friday. Every group will be assigned approximately 20 minutes for a presentation, and then 15-20 minutes of discussion. So what could have been done differently, what was interesting, what could have been improved, etc., etc. And if you would like, your group would like to continue with the project, we foresee 2 research mini grants worth $500 each. For instance, for data collection. For instance, we will be showing you how to pursue and deploy an online survey. It requires some funds. So this will be, for example, a grant that can cover data collection. It would suffice to cover approximately 500 responses, which equals to a general population of a certain country. So it's really enough, for instance, to implement this kind of task. But maybe you would like to access, for instance, some database that is paid. So we are also able to cover it. And this is actually one of the ideas of the SICSS, that participants are creating group projects, and some of them leave afterwards, are much more sustainable than the others, and there are even papers published from the groups that were actually established during SICSS. So the grants are, in general, the idea to keep you together and to support those projects that are that has the biggest potential. Let's say like this. So the last thing that I would like to mention is about communication. So our main communication channel is Slack. I hope you got used to use it so far, because we asked you to follow Slack discussions from the very beginning, and we can see that you managed to do it. So that's very great. This is actually the application that I think was originally used by mostly programmers. And now it's also used in different settings, also in academia. And it's also the way through which the SICSS global community communicates. Yesterday, I added you to the global workspace. So here you can network with participants from other locations. There are more than 600 participants, so feel free also to approach them. So yeah, Slack is our main communication channel. All the lectures, group exercises, and everything that takes place online takes place on Zoom, and we use only one link. So this is the link that is provided in the agenda. Also on Slack, wherever you see link, there is only link to that one meeting. So you don't have to change the meetings or something like this. If you have any questions, the best way to approach us is a direct message on Slack. And also, if you would like to have individual consultations with either programmers, with our speakers, who are also notified that you might be interested in talking a bit more in detail about their research. So feel free to approach them also on Slack. And also, if you would like to approach us as organizers with more research-related questions, also feel free to do so. We are here for you for the next 2 weeks, and we're really looking forward to this summer school. Some of you had the opportunity to get to know each other yesterday, but not all of you. Don't worry. You will be, as I mentioned, divided into breakout rooms. Also during lunch breaks, you will have opportunity to network, to introduce yourself. Also, if you did not introduce yourself on Slack, please do so on the general channel. Most of you did it, but if some of you still didn't do it, please do it. And I think that's all from my side. Do you have any questions related to logistics?
I think that you explained everything really clear, Łukasz. Thank you for that.
That's great. That's great, because I managed to do it until 12:30, which means that we arrive at the second point in our agenda, which is the lecture from Michal Ovádek. I think Michal is with us already.
Yes, I am. Can you hear me?
Yes, we can hear you well. Thank you
Great.
very much. So, few words of introduction. Michal Ovádek is a postdoctoral researcher at the Department of Political Science at the University of Gothenburg in Sweden. He is part of Europa project, which is actually organizing also a very interesting NLP workshops in Florence, I guess in October. I think the application is closed now, unfortunately, but maybe there will be another edition, hopefully. And Michal, as I mentioned, is actually developed an EuroLex package. So this is a package in R that allows you to access data on European Union law. And he will basically introduce you what you can do with this package and how you can apply, how you can treat the law as data. So Michal, thank you very much for being with us, and the floor is yours.
Thank you, Łukasz. It's great to be here. Great to see so many people being interested in computational methods nowadays. If I can share my screen, it will probably be ideal. So I have a few slides, as you can imagine. Okay, can you see the slides? Okay, great. So basically, this this class or this lecture, whatever you want to call it, this discussion, we can call it even, is going to be about working with EULO data, EULO data, or rather if you're coming from the kind of pure legal background that's treating EU law as data. And sort of what are the different things that we can do with it? How can we access it in the sort of most painless way possible? And yeah, I'll show you different kinds of applications. It's not going to be particularly advanced, I think, but it's going to kind of cut across a lot of computational topics. So we'll go from how do we obtain the data to, all the way to kind of machine learning and everything in between. So how do we visualize data? How do we, wrangle the data a little bit, because of course, even when you get data from an API, it can be still quite difficult to work with it, just right off the bat. So without any further ado, I think we can slowly move into the topic. I would just mention that if you have any questions, ask them at any point during the class. We can also reserve some time at the end. I don't have slides for 1.5 hours. We're also going to take a break in the middle. So if you have any questions at any point, relating to what is on the slide or what I'm saying, it's probably better to address that in that moment, and then we can kind of talk about it, having the visuals there as well. Okay, so I suppose most of you know what EU law is, because from the names I can tell that most of you are Polish. That's not a problem at all. That's actually very useful in this case, because if you're from a legal system that's outside the EU, maybe you would be less familiar with this. But in general, I will presuppose that you have a broad idea of what EU law is. It's basically the legal system of the European Union, right? And so that's a legal system that applies in all the individual member states. It interacts in different ways with national law. It actually forms a very large component of national nowadays, because of course, as you may know, if you know a little bit about EU law, when you have, for example, directives adopted at the EU law level, those are then transposed into national law. And so there are many different ways actually that EU law interacts with national law, and many ways in which it is taken over into the national legal systems. But you're quite likely to have already encountered it if you do anything related to law, right? This class is not really going to be about EU law per se. It's going to be more about what we can do with EU law data. And we'll be specifically kind of talking about this more computational approach, where it's not going to be very theoretical, right? So like in traditional social science research, you typically start from some kind of a theory. Here we are just going to go straight into the programming part. For better or worse, this is obviously not the only way you can work with data. You should probably most often have some type of a theory that you approach it with if you're doing research. But here, I'm not presuming that all of you want to do research per se, but maybe you just want to learn something practical about how to work with law as data. And as I said before, we're going to try to kind of cover different elements of the computational workflow. So that is, obtaining the data collection. Of course, there is, I think, already you joined towards the end of what Lukasz was saying, but there's different ways you can obtain data. Of course, if you're running a survey online or something like that, it's a completely different type of data that you get than if you're working with observational data. So here we're going to be really looking at the data that is already out there, right? It's produced by courts and institutions, and how we can take that and do something with it. And so we'll basically access that data. I'll show you how to do that. It will prepare the data a little bit. We'll visualize it in different ways. We're also going to tackle legal texts. We're not going to be downloading legal text because it takes a long time, but I can show you how to do that as well. And then we'll talk a little bit about some kind of basic NLP things, NLP standing for natural language processing. I suppose that the audience is quite diverse in the sense of what your background is, but so some of this will be repetition for you, but I hope that's okay. Okay, so most of the data that we're going to be working with today comes from the website called EURLEX, which is actually a website that's run by the EU, a particular agency within the EU, which aggregates all types of EU law data. So it aggregates data from the court, aggregates data on the legislative process, so on legislation and the different types of treaties that are signed by the EU. You can find all of this information there. If you have ever worked with EU law, you have most likely encountered this. This is kind of the basic page that you get if you select the judgment, right? So here we have a judgment of the Court of Justice. At the top, you can see the ID, the SICSS ID, which is something that we'll be using as well. It's kind of the most common ID in the EURLEX ecosystem. And essentially, we get all types of information, right? We get the ECLI identifier, different kinds of identifiers. We have some subject matter things. And then, of course, we have a lot of metadata, so data about the decision that we're looking at. We have, for example, the type of procedure. So this is a reference for a preliminary ruling. So this means that the case originates at the national level. Actually, it was referred by a national court to the EU court, and so on, right? So we have data about who the judge rapporteur was, the judge rapporteur being the person primarily responsible, the judge primarily responsible for writing the judgment. We also have something called an advocate general, which is a sort of a lawyer working at the court that advises the court on how to make decisions, sort of what should be in the decision. So it's a kind of something between a lawyer and a judge, but the opinions of the advocates generals are not binding. And there's a lot of other information that, of course, you can work with as well. So how do we get this data? So one way you could do that is basically build some kind of a scraper, right? So you navigate to the HTML website, and then you have some type of a basic scraping tool, which essentially will just read what is in the HTML file, and you convert it from there into data. But actually, all the information that you find here is found in a sort of underlying SQL database. And so we can access this kind of data much more quickly if we go straight to the source rather than if we try to get the data from the HTML website. And so this is what the purpose of the tool that I also built for R called, the library is called Eurolix. That's the purpose of this tool, right? It's kind of to make it easier to access the underlying SparkQL interface and to kind of just bring the data into R. Because most of you, of course, don't have the time to be studying different types of SQL databases and the code required to work with that. But essentially, what this package should make it a lot easier for you to get that kind of data. And so on this slide, you can see the R code already. So we load a couple of packages, not all of, so the first one obviously is the one about the data, and so the function that you see on the slide is the function from the package. So we first make a query. We say that we want any type of resource, so it doesn't matter whether it's a judgment or legislation or a treaty, but subsequently we specify the sector to be number 6. And as you can see, if I go to the previous slide, remember when I mentioned the SICSS number, it always starts with a number between 1 and 9. 1 stands for EU treaties, 2 stands for international treaties, 3 stands for EU legislation, 4 is also EU legislation, 5 is all types of documents like commission proposals, and 6 is court judgments and court documents, right? And so most of what I'm going to be doing today relates to working with court decisions. And so we specify the sector to be 6. And then we specify some variables that we are interested in that we want to work with later today. In this case, we want to know who the judge rapporteur on the case was, who the advocate general was, and what the court formation was. So the court can sit in different formations. It typically decides in a fair formation of 3 or 5 judges, but it can also decide in a sort of grand chamber, which is 12 to 15 judges, or the full court. So that would be nowadays, that would be 27 judges. And so that creates a SparkQL query that we subsequently run, which means that we send this SparkQL request to the Eurolix servers, and it's going to give us some type of a result. And the result, we can find it here on the data tab. It's going to look a bit weird. So first of all, you have a unique identifier, which is not going to tell you much, but that's basically the URL where you can find where you can find the data that you requested on. Then you have the SICSS identifier, right? So that's the one that I talked about, where the first number denotes the sector. Then you have the year in which the decision was made. Then you have the court, whether it's the Court of Justice or the General Court. So that would be T here if it was the General Court instead of C. J standing for judgment as opposed to order, which is an O. And then the number of the case, which is the last 4 letters, the last 4 digits. Then we have the name of the advocate general, which is what we requested, right? We have the name of the judge rapporteur. So AG stands for advocate general, JR stands for judge rapporteur. And then we have the court formation CF. And so there are different types of chambers at the court, and you can here see also the ground chamber. There's also some missing information, right? So that's something that we'll talk about in a second, but that's very typical for working with data. And so let's just try to kind of plot this information. And what you see when you try to just plot it is you just get this absolute disastrous result, which suggests that there's something very wrong with the data. If we just kind of take it as it is from the website or through the API. So we have to investigate probably a little bit more what is in the data to be really sure, to really understand what's going on here. And so to clean up the data a bit, this is something that I always recommend that you do. You have to kind of work with it a little bit, right? You look at it both visually, like, okay, what's wrong? Do I understand exactly what's going on, what all the variables stand for? So here we first select just the variables that we know we want. So that's the SICSS identifier, the judge rapporteur, advocate general, and court formation. Then we extract some more variables from the SICSS identifier. So we extract the year in which the judgment was made, the court by which it was made, and the type of decision, a judgment or an order. And then I kind of, just for the purpose of this exercise, I also filter out, I simplify the exercise a bit, right? So we're only going to look at judgments starting in 2005. We'll only look at the Court of Justice as opposed to the General Court, and we'll only use judgments as opposed to orders. And so afterwards, we get this kind of much cleaner data frame where you can browse through this a bit. I'll give you the slides at the end, or I'll give you the access to the GitHub page where they're hosted. And so you can see that we just have this kind of much cleaner data frame that will be easier to work with, right? One thing that we're always interested in if we're doing any type of data analysis is what is the proportion of data that's missing, right? So especially if you don't know exactly, you haven't kind of coded the data yourself, there's a very high chance of there being missing values. And this is something that you want to look into before you move into any kind of analysis afterwards. And so here I just very quickly plot the proportion of missing values. As you can see, it's not too bad. So for 4 variables, we have absolutely no missing values. That's the identifier. That's basically the identifier, the SICSS identifier. We have it for every single observation. And so the 3 variables that we created from that also are not missing any values. Judge rapporteurs, we have less than 1% missing, so that's very good. Advocate general, a little bit more, but that's still perfectly fine. And then the only kind of problematic area is the court formation, where we have more than 10% values missing. But that's still not too bad, right? I mean, in the out there in the wild on the internet, you're going to find data sets which are much worse in this regard. And this is something that, of course, you have to be aware of. Okay, so we had this disastrous plot before, right? And so can we kind of make something nicer than that? And the answer is actually, yeah, of course we can. So I try to plot the pairs of the combinations of judge rapporteurs and advocates general. So these are the people that tend to work most often together, right? And so this is a very simple plot where on the x-axis we have the different judge rapporteurs, on the y-axis we have the different advocates general, and we want to know which people work together the most often, because perhaps this is an entirely plausible hypothesis that people that work together more tend to build a different kind of working relationship that can have an impact on both the efficiency of the procedure, but also the substantive outcomes that come from that, right? Because the advocate general is in kind of a lot of contact with the judge rapporteur during the drafting of the advocate general opinion, but also during the drafting of the judgment. And so what you can see here is that there's definitely some patterns going on, and there's different differences between the advocates general and the judge rapporteurs and the different pairs that can happen between them. And so the one that is the most so obviously one thing that you have to bear in mind is you're not going to have the judge rapporteurs and the advocates generals. The number of cases they're going to be on is going to be conditional on how long they have on the court, right? So if they spend a lot of time on the court, they're more likely to receive more cases, and so they're more likely to be featured in one of those pairs. And so actually the the advocate general that is by far served by far the longest on the court, it's Juliane Kocher, the German the German advocate general. She is, you can see that she's by far at the top, right? So she has formed pairs which are stronger with several judges than any other pairs in the data set. And so this is just kind of a nice visualization that you can do with some very simple data. And actually, this type of data, when you have it's called relational data, right? You have relationships between different individuals, in this case, a judge and an advocate general. It's very kind of useful to deploy in a network type of setup. And so you can, in R, it's very simple to kind of take this kind of data and create a network. And I use a lot of the sort of tidy XX packages in this lecture, but of course you're free not to use them and use something else. You can recreate all these visualizations in different ways. But if you have this kind of relational data, you can use the tidygraph package to actually very quickly convert the usual data frame, right, where you have just two variables, into a sort of network type data set, which looks like this. This is a kind of tidygraph data structure which consists actually of two data frames which are linked. And so on the one hand, you have the data frame which contains the data on the edges in the network, and on the other hand, you have the nodes. And so the nodes are the individuals, so that would be the judges and the advocates general, and the edges are simply the connections between them, right? And the number of connections as well, because as we said before, if you look here, sort of the more red the tile is, that denotes more frequent connections between the advocate general and the judge rapporteur. And so once we have a structure like this, it's also very simple to visualize it using the gggraph package here in particular. So as you can see here, depending on who you are, you might be more central to the network or sort of more on the outer edges. The advocates general, of course, there's variation both among the advocates general and the judge rapporteurs, which has to do, as I said, with how long they've been on the court, but also simply the types of assignments that they get, right? Because that's not purely random. The way these people are assigned to cases is not random, at least not at the Court of Justice, because the president of the court has some leverage, quite a bit of leverage, in fact, in to whom he or she, or in this case he, assigns the cases. And so you're going to have this kind of more dense center, and the edges are obviously way less dense. Things that you can do with networks, as I said, this presentation is going to just feature a lot of different sort of techniques and things that you will hopefully be able to then use for your own projects. This is more kind of just what are the things out there that you can use, right? And so a common thing that you can do with networks is try to segment parts of the networks into communities. And so here I use something called Louvain community detection algorithm, which basically looks at the densities and the relative densities within a network, and it tries to basically group nodes into communities, right? So it assigns basically a label to each node depending on the kinds of connections and the density of its connections within the network. And so you can see here that basically for our network, it finds 1, 2, 3, 4 communities, and it's probably quite difficult to interpret the meaningfulness of these communities. I think one way you could do that is look at how long these people have been on the court. I would think, if sort of based on my own knowledge of EU law and of the individuals involved, I would say that the red cluster is sort of the cluster of the most impactful judges and judge rapporteurs. If you look at some of the names there, like the president of the court, Judge Leonards is there. You have advocates generals Bott and Sharpston, also Poyares, Maduro. Those are some of the most well-known advocates general. But of course, the interpretation of these unsupervised techniques is always something that you need to bear in mind, right? So like, how do you validate this type of setting? Here, I'm just kind of purely using it as to showcase what you can do with network data. I'm not trying to get at any type of substantive outcome. All right, so that's one way we can visualize it. But probably what more of you are going to be working with or kind of thinking when you think of like, okay, how to work with lawyers' data. well, there's one type of there's one part of the law which is particularly common, right? And that is the textual part. And so how can we leverage that, right? So obviously law consists of a lot of text, right? It's text upon text upon text. Like law is basically text, right? And then it also covers case law. Nowadays, of course, there is a movement towards also other types of data. So if you, for example, in your jurisdiction, you might have access to something like court hearings, you might have access to audio data or even to video data. This is sort of the next frontier for a lot of social science research, is trying to, leverage that type of data for some type of substantive outcome. But the textual data will probably forever remain sort of the centerpiece of the legal agenda, because this is simply how we communicate within law. And so what can we do with text? Well, we can actually apply the kind of whole gamut of analytical techniques that exist in computational social science on legal data as well. And so one could, if you've never done this before, the way you have to think about it a little bit is, how do you take the text, right, the raw text that you can read, and they're completely amenable to sort of the usual doctrinal analysis or legal analysis. How do you take that and like put it into a quantitative setting? And so what we need, first of all, is some type of a numerical representation of the text. And that numerical representation of the text will differ based on what you're trying to do, based on essentially the different assumptions that you might have about the law. The main two approaches here are called bag of words and embeddings. And so that I'm simplifying this, but a lot. But I want to just sort of introduce you to this kind of core distinction, and you will be able to complicate that or sort of build on that further along. And I'm sure there's going to be other courses in the summer school that will help you with that. But in the bag of words, which is really the basic way of conceptualizing text as data, we take any given text and we simply create a matrix where we count the occurrences of individual tokens, and those tokens are typically words, among the different documents that we might have in our corpus. And so in this very simple example, we have two sentences. The first sentence being, who let the dogs out, who. The second sentence being, the dogs were let out by someone, but I do not know who. And so how do we represent, so these are just two sentences that you can read. How do we represent them numerically so that we can use them in analysis, or in quantitative analysis, that is, more specifically? So first of all, we need to think of what type of information we want to retain from the text. Typically, you're interested only in the words, right? And so we know, of course, what words are. There might be some edge cases where it's not clear whether something is a word or is not a word. But in this case, it's pretty simple, right? So the words are going to be, so the words you can here find in the columns. So the columns show the words. This is all the words actually, right? So if I had to move it a little bit. And so here we disregard the order in which they appear, because of course the order of the words differs in both sentences actually, right? So in the first sentence, the word who appears in the first place. In the second sentence, it only appears somewhere in the second part of the sentence. And so then what we do is we simply count up all of these words, and we have this matrix, right, where we have the two sentences and the words, and so we have basically values for each. This is also known as a document term matrix or a document feature matrix. There are also some other terms used for this, but that's not, the vocabulary here is not particularly important. What you need to know is that this is the most basic type of representation of text. So again, this is really the sort of core way of starting with quantitative text analysis. Okay. What we typically want to do when we have these matrices, we need some way of comparing them, right? So when you're working with the law, you can look at two sentences and you can essentially in your own brain assess whether these sentences are similar or different, whether they talk about the same things or different things, whether they're maybe analogical, like it's basically the same thing, but it's slightly different, right? And so on. And you can make all these kind of calculations in your brain very quickly and very intuitively. But once we move to this mathematical structure of text, we need sort of more rigid tools for comparing documents and for comparing sentences and different units of text. And so the most common way of doing that is actually using cosine similarity. Cosine similarity takes two vectors. So in this case, okay, so in the previous example, we have a matrix, right? So matrix is essentially, in this case, we can say that it consists of two vectors. We can say that for each sentence, we have a vector, which is just this series of numbers, right? So that's the 0, 1, 1, 1, etc., etc. And so we have two vectors like that. And let's say that we want to compare them. How do we compare them? Cosine similarity is the most typical measure. There are many, many other measures. There are different types of assumptions built into the measures. So of course you have to consider whether they're appropriate for what you're trying to do. But this is, I would say, if you were to know only one measure to use in computational text analysis, it would be this one. And the reason actually it is this one and not another one is because as you can see in the previous example, the two sentences are not of equal length, right? And so that's going to also have an impact on the counts that you find in the matrix. But cosine similarity has this nice feature which you find in the denominator, which is that is normalized, right? So it's normalized, and so you don't have to worry about the magnitudes in the vectors. You only basically you can compare these vectors without having to worry about that particular aspect. That comes handy also for different reasons, not only when you're trying to compare text of different length, but this is sort of the basic idea. And so if we run this calculation on the two vectors, right? So you take the dot product, the internal product of the two vectors. So here, if you substitute x with sentence 1 and y with sentence 2, this is essentially what you get. It's 0.624. In the case of document term matrices, the value of cosine similarity is always between 0 and 1. 0 meaning the two sentences or two documents are completely dissimilar. 1 meaning that they're completely similar. They're basically identical. In this case, we get a value of 0.62, which means that which suggests that the vectors are quite similar. Another issue that we want to consider from a computational perspective is sparsity. And sparsity is a concept which basically denotes the proportion of zeros in a given matrix. And so if you again go back to the matrix on the previous slide, you see that there's quite a lot of zeros, right? Because of course the vocabulary that only appears in one sentence and not in the other, there's going to be a zero. There's going to be a value of 0, right, for that sentence. And if you try to think of something like the whole corpus of rulings at the, let's say the Polish Supreme Court or the Court of Justice or whatever other court, you're going to have thousands and thousands of words, but many of these words are not going to appear in all the documents, right? There's going to be some words like the, a, etc. They're going to appear in most of the documents, but there's going to be some words which don't appear in many documents. And so that means that you're going to have a very sparse matrix. You're going to have a very, very sparse matrix, which will essentially, the zeros don't give us too much information, right? So this is the problem with sparsity. Zeros are nice, and we have this like very neat matrix, which is like very complete, but it doesn't give us too much informational value. And so this is something that essentially we'll consider in the embedding context, and we'll try to kind of make the data representation of the text a bit more efficient, a bit more meaningful, and less sparse, actually, right? Another topic that you have to always deal with when you are working with text as data is the decisions that you make about the different the pre-processing steps, right? So as I said before, we typically are interested only in words and not in other types of tokens. So as you can see in the sentence, of course, there's other stuff, right? There's also commas and there is full stops in this case. In judicial text, you're going to have a lot more characters which relate to different things. And the question that you have to pose to yourself is, are these characters important for me? Are they meaningful? Do I want them to be part of my analysis, or do I only care about the words? And so those pre-processing steps are going to have an impact on the subsequent analysis, right? And another pre-processing step here that is very commonly applied in text data analysis is converting uppercase to lowercase, so that basically you don't care about the fact whether a word has appeared, for example, at the start of the sentence, where we capitalized, or whether it appears in the middle. And so what if we do that, if we put all the words into lowercase, we get a matrix which actually ends up being a lot less sparse, right? And you understand why, because we have fewer unique tokens, right? We have fewer unique words, which decreases the probability that we are going to encounter zeros in the matrix. You can also see that the cosine similarity has slightly changed. So in this case, if we do change the pre-processing and if we put all the words into lowercase, cosine similarity goes up a bit, right? It's a small difference, but in sparsity goes down. So those pre-processing steps, so this is a very minimal example, of course, it's only 2 sentences and very short sentences, but if you try to extrapolate these concepts to a much broader and much bigger corpora, so we're going to be working with, you're going to be working most likely with thousands and thousands of documents, thousands and thousands of words, those differences are going to be quite impactful, right? And they might be the difference between your analysis being meaningful and representing reality correctly, or being useless. So this is something to definitely keep in mind when you're working with this type of stuff. I think before we move into embeddings, I would suggest we have a 10-minute break, because I think it's a good moment to stop, because embeddings will be kind of its own thing. So how about we reconvene at 1:15? If there are in the meanwhile any questions, that you want to type up, or you want me to go back to some slides, we can also do that during the break. But I think it will be nice to take a bit of a moment here before we go into this.
Okay, thank you, Michal. So yeah, let's take a break. And as Michal mentioned, if you have any questions, feel free to ask.
Actually, I would have a question to you, because
Sure.
you mentioned earlier that you were not scraping the content of Eurolex, but you were accessing the SQLite database.
Mm-hmm.
I was just wondering, how did you do this? Like, was there an API already on the page, or like is
So there's a
reproducible for
SPARQL.
others, or?
Yeah, so there's a SPARQL endpoint where I can show you let me show you the different part of the slides. Need to exit this. Yep. Yes, you will have the slides, by the way. So this is just to answer the other question. You will have the slides. Sorry, I have to just stop sharing for a second because of this. Okay, so let me just show you the package a little bit so that you know what I'm talking about a bit more. Didn't want to go into the technicals of that, but of course we can also do that actually if you like. Okay, so if you want to know a bit more about how to work with the API, so this package is basically connects you to the API, but you can also obviously construct your own custom queries if you know something about SQL, and especially semantic web SQL, which is a bit more specific. So I can show you how it more or less works. So this is the main function. Basically, it just creates wrappers around SPARQL code that you can subsequently execute. But the endpoint is, sorry, that's actually a different one. So here, there's this endpoint. I think you can actually also, there's a website that you can navigate to. Yeah, so this is the endpoint that you can use to access their data. Yeah.
Ah, great. Okay.
Yep.
And because I usually, because I also work with like data on the web, but I usually use web scrapers, and I wasn't really aware of that you could also just directly access a database. So that's
Well, I mean,
something I would
it's up to
definitely look
they
into.
have to do that. Like it's not always available, right? Not
Okay.
all websites provide their own APIs. So
Okay, I see.
but it's of course very, like, I think it's kind of the way it should be done for many reasons, because of course you can optimize, like optimizing web performance is something else from optimizing queries for something like this, right? Like an endpoint. So this is typically much faster if you're just trying to get a certain type of data. But then again, you have to know how to build the queries, how to access the different variables and so on. So it takes some time, and it's complicated in its own way, in a way. So scraping is simply the easier option, I would say, right? So you can just
Okay.
go to the website, you scrape whatever you see, and that's much simpler than sort of learning, especially if you don't have like background in SQL. I don't know if you do, but if you don't have
Well,
background
I'm
in SQL,
getting
that's going to be,
into it a bit, but
yeah,
so, but no, thanks a lot for your answer.
no worries.
And we just have a question, Michal. Okay, whether you can share the slides afterwards.
Yeah, I already said it afterward. Yeah, I'll do that. I'll share the
Okay,
whole
thank you.
GitHub thing. Yep.
Okay.
Okay, so it's 1:15. I think we can slowly get back into it. Maybe just to begin with, I'll address this question by Yejay about where he basically is asking, can we use other types of similarity measures which are perhaps more intuitive? He mentions the Jaccard index. Like why don't we use that instead? And so I think basically the basic answer here is we could for sure. And as I said, I think you should always kind of try to justify why you're using a certain similarity measure and not other. The Jaccard index is more kind of set theoretical, if I remember correctly. So it's like more about sets and overlapping sets. So basically a proportion of elements that two sets have in common over the total number of elements, I think, something like that. And so this is similar to cosine similarity, but basically, I think I think it's just kind of path dependence. Because you have all of these options in choosing a similarity measure, once sort of the big players or the big models that people have used traditionally in, let's say, text analysis, resort to a certain similarity measure and it seems to work, like at some point people stop questioning it, right? And so if you want measures that are also comparable and you just kind of don't want to think about it anymore, you just adopt one as a standard. And in this case, I think the standard is cosine similarity. And so that people stop kind of questioning what measure to use, and I think that would be the explanation. But I think absolutely, like you're right, we could be using different measures, which could probably be more intuitive and perhaps achieve the same things, right? So I think it's more just a consequence of what is already out there, how people have done things traditionally, and this not being questioned at some point, rather than it being a sort of constantly a conscious choice of like what is the best and most intuitive measure that we can use. Yeah, but I think it would be maybe a good exercise for some of the kind of training that you do afterwards to have a look at how different similarity measures perform and what is the usefulness of each of them. We also have another question by Monica, who asks whether cosine similarity is also used in plagiarism platforms. I don't exactly know the internal workings of plagiarism platforms, but I would imagine that it's quite likely, even if it's not cosine similarity, it's some type of similarity for sure, right? Most likely what they're doing as well is comparing some vectors, some numerical vectors. So I don't know whether it's cosine similarity that they're using or another type of similarity, but for sure it will be something along those lines, right? So cosine similarity is just considered, it just became the standard, I think, mainly because of the property of the fact that you can disregard the length, like basically it doesn't look at the magnitude of the vectors, but rather the direction and the angle between two vectors. So I would say that's probably, I can't speak to whether plagiarism platforms use them, but I would say it's quite likely, yes. Okay, so I suggest with that, and of course keep asking questions as whenever you see something interesting or something that it doesn't really, there's no stupid question. Monica said that maybe her question is stupid. It was not stupid at all. It's completely legitimate. So keep asking questions if you have any. So now we're going to try to look at a different way of, so the first way of representing numerical, text data is this document term matrix with counts, right? So this is, as I said, the most standard, most traditional way. This is kind of the absolute basic thing that you have to know about when you try to work with text as data. But there are other ways, and they still start from this basic representation where you have the count data, right? Where you have the zeros, the ones, and etc., the integers. But they try to make everything a bit more efficient and provide a bit more information about the text. And so embeddings, essentially what they do is they take this type of matrix and they project. So first we're going to talk about actually word embeddings. We'll specify the differences there. But they project the tokens onto an n-dimensional space, that space being typically something between 3 and 800 dimensions big. It can be bigger, it can be smaller, but that's not the most important thing. and they use a co-occurrence of words in a given window. So that window can be something like I'm going to look at 5 words preceding the word that I'm looking at, and 5 words after, or it can be bigger, it can be 100 words. It doesn't really matter how big the window is for the purpose of the example, but that's essentially what happens. And then they use basically a shallow neural network to train to basically come up with a dense representation of the original integer matrix. The idea is that basically words that are going to have more similar meaning are going to be somehow similar. The word meaning here is loaded, but let's pretend that it's meaning for the sake of the example, that they're going to appear closer together in the embedding space. And so basically what you get out of a word embedding algorithm is a dense matrix with numbers which are on their own actually kind of meaningless. Like if you just look at any given number here in this matrix, right, it's like -2.8 or 0.999. These numbers don't really mean anything individually, but together they're supposed to capture something like meaning, right? I'm simplifying here, by the way, massively, and so if you look into the literature, it's going to become much more complicated. But I'm not trying to convey complexity, but rather that these techniques are actually useful and can be understood even if you don't have, let's say, like a massively mathematical background. So the main difference that you can immediately see between an embedding matrix and the original document term matrix is that you have no sparsity here, right? There are no values which are 0. And so this is kind of the point, right? We're trying to get rid of the zeros. We're trying to reduce the matrix in size, right? So that it's not so big, because if you think about the vocabulary that you can have in a type of bag of words setting in a normal document term matrix, you're going to have thousands and thousands of columns, right? Because you have to look at each word individually. You have to count up each word individually. And so this is a much more efficient way of representing text data. In this particular example, though, you can see that we have switched from having sentences in the rows. So in the observations are not sentences, but they're individual words. And that's because this technique is developed from just trying to embed individual words rather than documents. But nowadays, that technique has been extended, or nowadays, actually many years ago already, because the state of the art in this field moves very, very fast. And we could also be talking about bidirectional transformer models, which is a kind of another extension of embeddings, but we're not going to go into that. This is really just the basics of working with data, working with text as data. And so we can extend this idea of embedding words into a vector space to also larger units of text, such as sentences, paragraphs, or entire documents. And so we can basically, there are different ways we could do that. So we could, what we could do is just go to this matrix and just average. So we would have a sentence which says, let's say, let the dogs out, right? And we could select the words let the dogs out, and we would just average the vectors, and that would be, and then we have one vector for the sentence "let the dogs out," right? So this is a very simple way we could kind of aggregate. We could aggregate the words for larger units of text. But a different way, and I think this is more common, I would say, is to actually train vectors separately, so that you don't just average or somehow otherwise mathematically combine word vectors, but you actually create a vector from scratch in the kind of same neural network process that you use to train word embeddings. You can also train document embeddings. And we're not going to go into the details of that and how neural networks work, but basically in the very sort of simple setting is what you do is you simply add an ID for the unit of text that you're interested in to the training process, and you're trying to simply predict the same task as you would with the words, but you do it with the document ID, and that way you will generate vectors, document vectors as well. The main thing is that basically what you get afterwards is you have everything in one vector space, right? So you have words and you have documents, and they have these numbers typically these numbers, as I said, are somewhere between 300 and let's say 800 dimensions. In our example, we're going to be using 500 dimensional vectors. So that means there are 500 numbers for each word and for each document. And the main thing is that we have them together, right? So we train them all together and they appear in the same vector space. And so that means that this idea of similarity can be leveraged to understand the similarity between different documents, but also the similarity between words and documents. And so how do you, but you have this question, right? So we are always interested in visualization and computational social science. How do you visualize something that has 500 dimensions? And the answer to that is that you don't, right? I mean, we are simply not capable, humans are not capable of kind of comprehending space in such dimensionality. What we typically do is we try to take a lower dimensional projection of something so complicated, and typically just a two-dimensional vector space, right? So we only have 2 dimensions, that's the x-axis and the y-axis in any given plot, so that this is how the human brain basically works, how it understands visualizations. And so in this case, it's going to look something like this. So what I do here is I train word and document embeddings using a corpus of something like 150,000 paragraphs from the Court of Justice, right? So the Court of Justice rulings, I take just the last couple of years. This is just a toy example. I train word and document embeddings. So we get these 500 numbers for each word and for each document. And then I take these 500 numbers and I use principal component analysis just to extract the 2 first dimensions, which summarize the most variation in the data. And so this is an interactive visualization, which will show you. So we have the words in orange and we have the documents in green. So here we have, for example, a word health, and we have another word, which is automotive. And we have a bunch of other points here, right? So if we look at, so we have another word here, which is cars. And on top here, we have victim, crime, and criminal. So this is a small example where I only show some words and some documents from the model, right? I don't show you all the words because, of course, there's thousands of words and there's thousands and thousands of documents. So if I try to put it all into one plot, it's going to be very difficult to understand. But the basic idea here is that we should see words which are similar to documents close together in the vector space, and if they're not similar, they should be further apart, right? So this is the basic idea that I'm trying to convey here. And so, for example, here we have a paragraph which comes from a ruling that has this ECLI number. So the ECLI number is something that you may be familiar with. It's an ID. So it's a judgment from 2016. This is just one paragraph, and this paragraph says, it's actually just one sentence. It is apparent that the proceedings in question before the National Court are not criminal proceedings, right? And so you can see that this word appears very close to the word. So this sentence appears very close to the word victim, which makes sense because it's a sentence about criminal proceedings, and victims are typically part of criminal proceedings. And at the same time, you can see that it appears quite far from the sentences at the bottom, which are actually about cars, right? So there's here, for example, this sentence says cars referred to as sports cars are high performance cars and therefore capable of being used in motorsports. And this is a sentence that appears in a ruling from 2020 in some like random thing, right? But this sentence appears close to the word cars. And so this is what we would expect from the embedding model to do, right? But this is a very powerful way of representing text data because we don't have to look literally for every individual word, but we can sort of capture some type of meaning, right? Which is really nice because otherwise we will always have to be just looking for like the exact match. So for example, you could even have documents appear here, which would be about cars, but would not even contain the word car, right? It could contain a similar word which captures the same meaning, but it should still appear relatively close in the vector space to the word car. And the same thing goes like basically you can hover over these and see. So here, for example, we have the value of those 3 types of passenger cars. Actually, wait, this is wrong. Okay, the visualization is not working properly. I see now because reasons. But anyway, this is, so for example, this paragraph says the decision may be issued by an authority other than the court in respect of criminal offenses and acts which are punishable under national law. And it's a document that appears again, close to the cluster of other documents which are about crime, criminal, victim, etc. We could add other words similar to the criminal proceedings, right? And they should appear somewhere in this upper top right corner. Maybe one thing to mention is that, actually, no, we can probably leave it at this. Is this more or less understandable? This is, a very simple projection of Word and document embeddings. One thing that you have to keep in mind, of course, that this is like the most simplified level that we can show this in, right? We have 500 dimensional vectors that capture the meaning, right? So there's 500 dimensions, and we only take 2, and we try to summarize these 500 dimensions into only 2 dimensions so that we can visualize it in this simple way, right? But normally, if you try to use it in analysis, you would use the full 500 dimensional vector, right? Because you want to capture the whole thing. So this is only for the purposes of visualization. You would kind of go to this very simple 2-dimensional level, just so that we can kind of see what is going on underneath in the model. Okay, so that's, I think, embeddings roughly covered. We've still half an hour, so that's fine. Just to maybe recap what happens here. We take a bunch of documents, in our case, paragraphs of CJU decisions. We create a document term matrix, which counts the number of tokens, in our case, words, in each document. And this is a huge matrix, right? So this is thousands of words, thousands of columns, times thousands of paragraphs. So that's, massive. That's like hundreds or millions. There's millions of values, actually, right? And it's very big. It's difficult to fit into memory and so on, difficult to work with computationally. Then we use a neural network to embed these words and documents into a 500 dimensional vector space, capturing the relationships between words and documents. And this matrix is much smaller, of course, because now we only have 500 columns instead of thousands of columns. And to visualize it, we reduce the dimensionality further. So you can see this is kind of a iterative dimensionality reduction exercise to reduce the embedding matrix to only 2 dimensions, so that we can have this kind of very simple visualization. So this is the basic idea here, I would say. Okay, so that's embeddings in a nutshell. Those are, I would say, the 2 main, 2 very basic approaches to text representation, but pretty essential, I think, if you want to work in this field, or if you want to be working with text as data. And finally, I have a very simple sort of pipeline to show you how to do machine learning in R using the data that we originally got from the API, right? So machine learning is a very fashionable word nowadays. It's probably a subset of even more hyped up words like AI, which I prefer not to use. I mean, you're going into this field, computational social science, so you should be using terms which are as precise as possible, I suppose, so that you know exactly what you're talking about. And so what we're going to be actually doing is logistic regression, just without any sort of underlying theory. But there's also obviously much more complicated machine learning models that you can use quite simply, and I'll show you how. So what we want to do in our exercise here is we want to know what types of cases are likely to end up in the grand chamber of the Court of Justice. So the grand chamber is when there's more judges on the panel, right? So this is a very kind of simple thing that we want to know. Like, what are the possible drivers of this, right? Because of course, again, this is not random, right? So the court will somehow select cases that it wants to allocate more judges to, right? And the grand chamber is typically the chamber where the court decides on new directions in the case law, right? It kind of creates new doctrines, whereas this is less likely to happen in a smaller chamber. And so we'll ask a machine learning model to predict whether a case, based on a bunch of input variables, and not too many, because this is just a toy example at the end of the day, whether these cases end up before the grand chamber or not. And also, what is the relative importance of these different variables? This is the absolute most basic machine learning problem. It's a binary classification problem. We only want to know if yes, it is a grand chamber, decision, or no, it's not. So this is really, if you want to learn about machine learning, this is where you typically start. So first of all, we need more data for this type of exercise, and one maybe proxy for one type of variable that we can try to look for that maybe it's useful for this exercise is the citations in a given ruling, right? So what we do here is we go back to this API and this R package that I created, and we ask it to give us citations for every decision. So that is, whether the court cites and also what types of citations. So like it's going to give us different kinds of citations. It's going to give us citations of EU treaties. It's going to give us citations of international treaties, legislation, case law. And so we group all of these together in these 4 categories, because perhaps there are differences between them. Maybe some types of citations are more indicative of a grand chamber ruling than others. We don't know. We approach this with, again, no theory. We just pretend like we don't know anything about it. We just give it a bunch of variables and we ask the model to tell us what are the likely predictors. For those of you who are only starting out, there's this thing where you can have data in a long format or a wide format. For machine learning, you typically need data in a wide format. That is, you want every single column to be a variable as an input into machine learning. So that's what we do with the final step, where we just take that data and we transmute it into this wider format. So this is the data we get for each case. As you can see in the first column, the CLX again is our identifier of the cases. For each of those cases, we get a number of citations. So basically for case, let's go to something more recent. So for case 6/2006 TJ 116, we have 0 EU treaty citations. We have three times some kind of EU legislation being cited. We have 24 references to case law and 0 references to international treaties. So this is the basic structure. Then what we do is we merge this into our main data set that you may remember from before. The only difference here is that instead of having a court formation variable, we have a grand chamber variable, GC, which only tells us whether the case ended up before the grand chamber or not. So if it didn't, it's a 0. If it did, it's a 1. It has to be a factor for most machine learning input. You need to code the data type as a factor rather than as even though it's numbers, it has to be a factor. And then we have the variables that you already saw before. We have the judge rapporteur, and we have the advocate general. We also add the procedure. So there's some basic types of procedures in EU law. The most common one is the preliminary reference procedure, which is when the national court refers a case to Luxembourg. But there's also annulment procedures when an act of EU law is explicitly challenged before the Luxembourg court. And then there's infringement procedures, which is when the Commission sues one of the member states, right? So it brings it before the court, and there is a case. And there's also other types of sort of less important kinds of cases. In addition to that, we have the year, and then we have the 4 variables which relate to the citation data, right? And so we just put this all into one data frame, and that data frame is the input for our machine learning model. You can browse through it a little bit. You will see it's very simple, nothing too fancy. I'm going to be using the title models framework, but you can use whatever you want. I usually actually do most of my machine learning in Python, but I did not want to complicate the seminar anymore by bringing in another programming language into this. So we're going to do it in R in this title models framework, which is a sort of a coherent language for machine learning. We'll basically follow the absolute sort of basic pipeline that you can have in most machine learning. Is you split your data first into a training set and a test set. Sometimes you also have a third validation set, but in this case, we will only have a training and a test set. We'll use part of our data to train. Okay, so the question is, why do you prefer, sorry to interrupt this. We have a question from Patrick. Why do you prefer Python to R in machine learning? I would say Python scales better. It's used in more production. So like it's kind of I would say from the get-go, it's a bit more scalable. You don't have to, if you look at the sklearn, especially sets of packages, sets of modules, it's a very kind of simple and quick way of doing machine learning, I would say as well. So there's a bunch of these reasons. I would say there's no, like for most applications, there's probably no difference. But if you have massive amounts of data, which I sometimes do, I would say Python is a bit kind of, there's less hacking around to be done if you just need to execute some model. But I think you can do most things in R as well. We can get into this discussion maybe in a moment if you want to continue it, like the language, the programming language wars. But ideally, we don't dwell on it too much. So first of all, we split our data into a training and a test set. So we'll use the training set, of course, to train our model, and the test set to evaluate its performance. Because if we just had one data set, then the model would, of course, learn. There will be no predictions possible, right? Like it would just kind of know the answers in advance, right? Because we would give it all the data in advance. But that's not a kind of a very practical way of using models, because typically we need to feed them new information that they haven't seen before. So in this case, we kind of do that artificially by splitting the data that we already have into two sets. Second, we train the classification model in the training set very simply. And then the third step, as I said, we'll evaluate the performance. And we'll do this quite quickly. We have 20 minutes left. That should be more than enough time. So I think in the title models framework, it's probably the most similar thing to sklearn in Python, in the sense that it's quite intuitive, I think, to do these things. So as I said, we're going to have this split. We're going to use 3/4 of our data to train. This is kind of arbitrary. I think most people use 75% to train and 25% to test. But you might get different results based on that. Maybe a different split is better for you. It always depends on your data and what you're trying to do later on with the model as well. So there's a lot of kind of moving parts. But in general, I would say something between 2/3 and 3/4, or even a bit less test data is the standard. And so then we have the all data frame, which is split into a train data and a test data, 2 data frames. We'll start with the absolute most basic model that we can use. It's a simple logistic regression model, which basically it just takes the input, and it's just a linear combination of the input variables that best predicts the classes that we're interested in. So in the title models framework, it's only three functions to create a model. And then we add this model into a workflow. That workflow can consist of also of other things. But because this is a very simple example, we only have a formula whereby the quantity to be predicted is 1 or 0. That's the GC variable. And we use all the other variables. So this is how you can denote it in the formula, just by using a full stop. It basically selects all the other variables in the data frame as the predictors. We train the model. Again, very simple, just a single function. And then we predict. So we have the predict function, which you might be familiar with already from just a basic regression setting. It just uses the same functions to do that. In machine learning, it's quite typical to be doing confusion matrices. Confusion matrices take true positive, false positives, true negatives, and false negatives to kind of compare the performance of the model across these 4 main quantities. As you can see, we have correct predictions on the diagonal. So that is 1,165 cases where the prediction should be, where the truth is 0 and the prediction is also 0. So this is good. Then we have 22 cases where the prediction is 1 and this is also the true. So it was a ground chamber ruling, right? And then we have 21 and plus 127, so 148 cases of misclassification, right? So that's where the model did not perform well. And actually, you can see that most of the time, when it was actually a ground chamber ruling, so that is 127 cases, the prediction was that it was not. So this is the more common type of error for our model. Usually you want to summarize the confusion matrix using different types of measures, different types of metrics. One thing to look out for is whether your data set is balanced. So a balanced data set is one that will have a similar proportion of zeros and ones in the outcome variable, right? So this is, in our case, that would mean basically that 50% of the cases in our data set are grand chamber cases, and the other 50% are not. In most real-world applications, unfortunately, your data is not going to be balanced. This is simply how real-world data is. Real-world data typically is not balanced. And so you will have to deal with this question of, first of all, what can you do about imbalanced data? And I'm not tackling the question here. What you can do, for example, you can randomly undersample from the majority class in the training set so that you don't train on, you don't have so many examples of the zero class. Or you can create synthetically the ones, right? So you can take some cases where you have, let's say in this case, a grand chamber ruling, and you can try to kind of create similar cases based on the input variables so that you have more of these types of samples in your data set so that there's more data to be learned from. And there's also many other techniques to work with imbalanced data sets and to address the problems that they create. But just purely at the level of evaluating performance, the basic measure of accuracy is not incredibly useful for us because if you don't have a balanced data set, the fact that you can predict the majority, the vast majority in this case, 89% of all the cases correctly, still doesn't necessarily mean that your model is performing too well if you take into account the imbalance in the data set. And so I would say the most also supported in the literature measure for this, so if you want to take into account class imbalance, is the Matthews correlation coefficient. Another one is the kappa coefficient. And so what I would say the MCC is the most common way of kind of taking that into account. And so if you look at the performance based on the MCC, you can see it's much lower, right? So it's only 0.23 compared to the normal accuracy score being 0.89. So this is definitely something to keep in mind when you're working with your own data. This is just a toy example, so we don't really care about the results too much, I have to say. But clearly, the performance is not amazing. We would probably need different kinds of data to be able to predict that in a better way, right? You can think of other types of variables that you could add to this model to make it better. And actually, one more thing that we can look at is, what is the importance of the different variables that we put into the model for the predictions. And as you can see, by far the most important variable that the model uses to predict the classes is the EU treaty, which is the number of times the court cites an EU treaty, or the number of different actually EU treaties that are cited by the court in the ruling, right? And so this is, according to the model, the best predictor of whether it's going to end up before the grand chamber or not. Right, so this is a very simple way of going all the way from just gathering some data using an API to training a machine learning model. Swapping in a different machine learning model is very simple in the tidy models framework. So basically the only thing you have to change is the model variable. So here, for example, you can use a random forest model, and then you just put it into the workflow as before, and you train again, you test, and you will get some results. One thing I'm not going to tackle here is for hyperparameter tuning. This is a whole other thing that you can do, of course, with machine learning, and you should be doing in principle to find models which are appropriate for your task, for your research objectives, but it's not something I'm going to be looking into here. Another topic is, of course, k-fold cross-validation that you have to use in those cases as well. But you can look into the appropriate documentation, and I'm sure you can figure it out, and I'm sure you'll have more classes on that as well later. I think ideally in your training sessions, you will try to beat the score on the slides. So the score was 0.23 MCC. So Matthews correlation coefficient was 0.23. If you can find a model, or if you can fine tune a model, find parameters that will beat the scores on the slides, it would be really good. And I would be interested to know who won this little competition using this data set. So basically what you'll have to do is just, you'll get the slides and you'll get the code and you'll be able to replicate all of what I've done here. But you can train a much better model, I'm sure, than the one that I've trained. And so I would like to see who wins this competition and what type of model that you use to do that. Okay, so that's more or less it. I'm not sure if there are other questions. I have one more thing that I can show you, which is not about case law, but it's about legislation. And so this is a little website that I put together using R, Markdown, and GitHub Actions, which automatically updates every night and uses this API that we also used in the slides. And it's basically, the purpose of that is that you have a constantly updated, overview of EU legislation, so that you can build very nice applications like this using this API. If you are interested in doing that, I think it's a good exercise for coding. So what it does is basically it asks the GitHub servers to execute some code every night and update this website. And so we have a constantly updated overview of the legislation. You also have the code here if you want to, reuse some of that in your learning. That's totally fine. And there are different kinds of visualizations. This is really kind of another, added more examples of what you can do with EU law data, depending on your interests. Of course, I cannot cover all your different interests here, but I hope that you have found something here that will be useful either methodologically or substantively when it comes to the data. This also includes, by the way, more interactive visualizations, which are nowadays very easy to do with packages like ggiraf and running regressions, the usual kind of research stuff. So yeah, that's about it from me. I don't know if there are any other questions. I'll be happy to address them, of course. But if not, we can probably slowly grind to a halt.
Thank you very much.
Sorry.
Yes, please just raise your hand so we will collect the who would like to ask a question. Okay, Julia, please go ahead.
Okay, sorry. Now I would have one more question to you because in the machine learning model, I think previously you mentioned that you were also counting articles and citations.
Mm-hmm.
And I was just wondering, did you use like a package for that, or you just used regular expressions, or how did you?
So no, so the citations are part of the metadata. We can argue about how reliable it is, but in the slides you can see, and if you want, I can show it to you again. If I just share the screen, sorry, one sec. I can show you. The code is there for the extracting the citations from the API. It's quite simple. Yeah, so you can see it here. So this is the slide where you have the citation. So again, we build a query, right? We ask it to include the citations, include citations equals true, and that's going to gives us this data frame with the citations, and then I just have to wrangle the data a little bit for it to fit into the right format, but basically it's there in the.
Okay, so you don't know how they do this, or do they just mark these citations manually, or?
Yeah, it's a good question. I think they use some type of software to do that.
Okay.
But I'm not like it's clearly not reliable, because if you try to actually analyze it in detail across the entire time period of EU law, you'll find that there are some problems with it. So I'm separately involved in a project which basically rebuilds these databases from scratch and makes them complete and fixes all of these types of problems. But for the sake of a reproducible example, this is I would say sufficient. The data is more complete in the later periods than the early periods, which also makes sense. But no, I don't think they do it manually. To be maybe it's like a mixture of manual input. No, I think there might be some manual stuff as well, but it's not clear.
Okay, thanks.
Philippe?
All right. Hi, Michal. Good to meet you, and thank you for the package. I've been playing around with it, but I still need to work on my coding skills to enjoy all of the possibilities. I was wondering whether it is possible to apply a filter at the level of constructing the query, because I saw that you had a filter, for example, for the year, like post 2004 for downloading all of the judgments. Would it be possible, for instance, to download judgments that are only in Polish or Greek or another language? Or for instance, would it be possible to exclude judgments that have not been translated into English, because it happens that some of the judgments are published only in French or German and have not been introduced or translated into English? So is it possible to do that on the level of constructing the query, or should I just download a whole data set and wrangle the data afterwards? What would you recommend?
Great question. I think so basically all judgments are available in French. Some of them are not translated into English, but for like the other translations, I'm not sure. I'm not sure if there's a variable which tells you which languages they have been translated into. I don't think so. Like, so basically the package is only like its use is quite limited compared to what you could actually do with the queries if you build them yourself, if you build them from scratch. Like there's a lot more stuff that I haven't kind of translated into our code. But I don't think that this particular variable would still be there. I don't think they have that. So this is something that you probably need to get through scraping. Yeah.
Okay.
If you want to know like which languages it's available in. Yeah, I don't think there's a variable in the metadata about that. But maybe I'm wrong, because it's there's so many metadata variables there that it's incredible. Like if you look into the documentation of the underlying database.
All right, I'll look into that. Thanks.
Okay, and Gökhan, please go ahead with your question.
Hi, thank you very much for this great presentation. Actually, I missed 1 or 2 minutes. I was away, so maybe that you mentioned that thing on that. Can you just put an example or put it in context? For example, can we just do look at the 7 years of judgment from 2015 to 2022 and find the relationship between one independent variable, like some sort of a political situation in one of the countries, and how it affects the EU judgments or even EU legislation, for example. Like, for example, the immigration crisis, how can we relate it with this? Is there a way to do that? Or can you just give it a little example by using the code?
Mm-hmm.
Yeah, well, the thing is, personally, I'm just trying to understand the language, all of these language in the codes. But if you just give a context on the one example that how do we explain the things?
I mean, so this is, I mean, more like a research design problem than I think a coding problem, because so first of all, you need to know what you're interested in, right? So you say, what is the impact of, let's say, the refugee crisis on EU legislation, right? Yeah. And so first you have to kind of define a quantity of interest. So like, what would be, what would be a measure of the EU part, right? So like, what are you interested in, let's say, legislative efficiency, right? So you could, for example, say maybe the refugee crisis like takes away attention from the normal legislative process, right? Perhaps there's like less time to create legislation, and so maybe less legislation is going to be created as a result of the refugee crisis. So this could be like a hypothesis, right? This is one way to also think of like quantitatively, like what kind of impact you could actually observe. But this is probably not the best, right? So first of all, you have to kind of define it for yourself, like what is going to be the measure of change, like what is interesting enough for you, right? And then another thing is, of course, what you can observe, and then only afterwards you kind of implement it in code. And so if I were to implement an idea like this, I would take, we have, by the way, some ideas in the chat about this, which is interesting. But for example, right, I could take like the number of legislation create. So like, actually we can go back to this output here. Wait 1 sec, I'll just share the screen again. So you can look at this graph here. And so you can try to think of like drawing a line in like 2015, right? And trying to think whether the refugee crisis had an impact on the quantity of legislation that comes out of the EU. But of course, in such a setting, the main problem is like causal inference, right? Like how do you attribute that type of change to just a single factor when there's many other things happening at the same time, and many things might be endogenous to other things as well. So this is more of a kind of methodological challenge, I would say, than anything else. But that doesn't mean that you should not think about it. Like it's, even if the conclusion is we cannot say that, or we cannot come to that conclusion, that's already a step forward than just kind of vaguely wondering what could be or couldn't be, right? So try to think of like a setup like that is meaningful. And there's obviously tons and tons of econometric literature about how to do these types of things, or how, like, what is possible and what isn't.
Mm-hmm. So we can find the literature on by using the statistical methods and the outside politics. How do they affect you, legislation and court decisions? Is that correct?
Well, I mean, it's what I'm trying to say is it's a vast topic, right? It's going to have
a
lot of elements. There's a lot of elements, but like what I'm saying is probably your main challenge in a thing like that is to be able to causally identify the change that you're interested in to just a single factor, right?
Yeah, exactly. Well, it was just an example, but yes, but I got the whole picture. Yeah, thank you very much.
Okay, cool.
Thank you, Gökhan. And we have also one question on chat from Agata, which actually refers to working on PDFs. Mm-hmm. Is there any special package to convert it? And
yes,
actually, what is the best solution that you would recommend, Michal?
Okay, so I have, luckily for you, I have a lot of experience with this. So yes, so there's the website, you have the PDFs. Let's say you download the PDFs that you're interested in. What can you do? Okay, let me share my screen again so I can show you some of the things that you can do quite easily. So the most cheapest and most popular way is a package called Tesseract, OCRR. So it's this package. You can use this. Basically, what you do is you give this, you give the main function, which I think is called OCR or something. OCR. You give it either a URL or just a file on your disk, and it's going to give you plain text. It's going to convert it into plain text. It works fine for most things. Especially for bag of words approaches, it's okay. For approaches where you need the sentences to be complete and in the correct order, it's going to be more complicated, more problematic. So there are obviously limitations, but the best thing about it is free. If you want the state-of-the-art optical character recognition, you have to turn to Google Cloud. Most likely, okay, I'm not signed in, but basically that's probably the state-of-the-art, right? So those are kind of very advanced machine learning models that Google has trained on millions and millions of documents, and they're going to give you better performance than the Tesseract package, but they're not free, of course. So you have to sign up. They don't have I think there might be actually an R API for this now, but typically we'll have to know Python or another programming language to be able to feed the documents to the Google API, and then you're going to get some result back, and you have to be able to work with all of these things. That takes a little bit of time to learn, but that's the state of the art, I would say. If not Google, then maybe Microsoft Azure is probably at a similar level when it comes to OCR.
Okay, thank you. Do we have more questions? If not, I have just one final question to wrap up a very interesting lecture. Actually, it's a bit more personal one, but it would be very useful, I think, for persons who are starting their journey with our programming and programming in general. So how and when did you start programming, and what would be your major advice for persons who are, about to start it?
Right, so I started programming only during my PhD, so like maybe 7 years ago, something like that, maybe 6 years ago. And I started programming in R. I mean, I had a little bit of like background during high school, but it was nothing very major. Like my math results were really bad all my life and so on. But I still kind of, out of necessity, I suppose, or out of interest, I got into it. And the best piece of advice is really you have to do your own projects, right? You cannot learn programming theoretically. You can look at examples and get inspired about like what's possible and so on. But the number one way of learning programming is by executing your own projects. And it doesn't matter how bad your code is at the beginning. It can be the ugliest and worst performing code in the world. It's just about getting the task done, right? And obviously, as you do more, you'll become better. But you become better by doing things, not by reading about things, right? So I think this is the difference between, let's say, general academic learning and programming. It's all about your own projects. And obviously, the more passionate you're about your own project, the better, because that's what you need. Right? You need motivation. You need reasons to be looking into it. You need a reason sometimes to spend the whole night trying to figure out something that many people have already probably figured out before you, but you need to kind of go through that process as well. And maybe one more piece of advice is that you just have to know how to search for information, right? So this is another thing that you learn. Programming is, you never know everything, right? It's not about keeping everything in your head. It's about knowing where to look for information. And most likely the problems that you're encountering, someone has already encountered them before. So, Stack Overflow and all of these things are your friends. You constantly search for stuff. I do it every single day, right? I mean, sometimes you learn something 5 days later, you don't know how to do it anymore. You search for the same information again. It's part of the journey, right? It's just how it works.
Okay, thank you. That was really inspiring, I think. So we can all learn it because none of us has a background except from Jędrzej, who is actually studying mathematics and law both. So any other questions? If not, I think that's all for now. Thank you very much, Michal. It was very interesting lecture, and we are very thankful that you could present your research and methodologies that you use.
Perfect. Thank you very much for having me, and good luck with the summer school. I hope all of you guys end up, programming your own little projects and doing something with computational social science, because I think it's very exciting. It's kind of empowering. It gives you, a lot of new tools that you wouldn't be able to use otherwise. Create new insights that you can't do without them. So it's a lot of fun at the end of the day, I think.
Thank you. So yeah, now I have just few announcements related to logistics and organizing stuff just before we move to the break. So I forgot to mention a very important organization that helped us in setting up the whole event, which is actually the Student Scientific Association of Constitutional Law working at our faculty. So a lot of thanks to the students that supported us in promotion. I don't know how you received the information actually about the school, but apparently it worked, all different channels that we used. One kind reminder regarding filling out the onboarding form that we sent you in the email some time ago, and maybe we will share it also again on Slack. So please just we'll share it during the break. So just please fill it out today, tomorrow. It will allow you to stay in touch with the SICSS community in general. And the third announcement is about exercise that we'll have actually with slight delay. We will start exercises at I would say 3. So 15 minutes later than in an agenda. We'll have a slightly longer lunch break. And during the lunch break, as we mentioned, we create 3 breakout rooms to discuss projects from Julia. It's about privacy policies. From Mikołaj, it's about natural language processing in general. And one more about media and democracy. I forgot now who submitted that project. Anyone maybe remind me?
I submitted it.
Okay, Saria, exactly. So these are 3 breakout rooms that will be created. They will have the names of the project, or like, the keywords in the name. So feel free to join whichever you would like breakout room and discuss basically with a person who proposed the idea, whether you would like to work on it, maybe deploy some techniques that Michal suggested, and Also enjoy your lunch, and we reconvene at the plenary session at 3 p.m. Okay, and feel free also to go between the rooms. You don't have to stick into one room. So feel free to discover different ideas and engage into the discussion, and also introduce yourself at the beginning. That would be very nice. And one question from Susanna, I see, please.
Sorry to bother you with that, but I'm not sure if I know how I should join the breakout rooms. I know how to divide, but I'm not sure. Is there any button in downstairs that shows that there are 3 breakout rooms open or whatever? Could you explain that a little bit?
Thank you very much. That's very good question, because there were no breakout rooms, but they were just opened now by Wojtek. Thank you, Wojtek. And you can see, I think, when you click on the Zoom more, you should see the breakout rooms, and you can assign yourself to whichever room you prefer.
Thank you. I see it right now. Thank you very much. I know how this works. Right.
Perfect.
Thank you.
So, any other questions? I can see no questions. Hazal, please.
I'm so sorry, but I still didn't understand how to find the slides. Is it available right now, or are we going to take the slides afterwards?
The slides, you can pick up slides afterwards. I mean, we'll collect it from Michal and post it on Slack. So
okay, great, thanks.
Then no worries. And you can approach us if you have any other questions. You can always approach us on Slack or in private message here on Zoom.
Okay.
Okay. Any other questions? If not, enjoy your lunch. Please assign yourself to the breakout room that you would like to have a discussion during the lunch, and we see each other in 49 minutes exactly at 3 p.m. Okay. If you encounter any problems in joining breakout rooms, we can also assign you to a breakout room that you would like to be into. So just let us know.